On May 29, 1944, the Boeing B-17G flying fortress, known as Shoo 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 Baby, ran into engine trouble during the mission to Posen, Poland. As the aircraft neared the target, one engine began smoking and was shut down. Over the target, another engine was damaged by flak. A third engine was lost only as the bomber approached the Swedish coast, turning a dangerous emergency into a race against altitude. Unable to make the long return to England, the aircraft commander turned toward neutral Sweden, the nearest realistic refuge for a bomber losing power and altitude. The diversion was an operational necessity driven by survival, setting off a chain of events that would pull the airframe away from frontline combat service for decades. The aircraft was on its final wartime mission with the 91st Bomb Group when the damage occurred. A mission count reported as 23 or 24, depending on how aborted sorties are counted. With 3 engines gone, the bomber's performance margin disappeared. The aircraft relied on 4 Wright R-1820 Cyclone radial engines to maintain altitude and forward airspeed, and with only 1 engine still producing power, asymmetric thrust and drag from the dead propellers left the crew with no practical route back to England. Still losing altitude, the crew force landed the crippled bomber at Bulltofta Airfield in Malmö, Sweden. Landing a military aircraft in a neutral country immediately invoked strict legal boundaries. The crew and aircraft were interned, and Shoo 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 Baby remained in Swedish hands after the men were later repatriated. Through diplomatic wrangling, the airframe became part of a broader exchange in which B-17 fortresses in Sweden were turned over for conversion and civil use. It ceased to be an active combat asset and became a diplomatic captive, isolated from the massive logistical network that sustained the wartime fleet. Decades later, the physical reality of that diversion left the aircraft in a perilous condition. After its final civilian flight in 1961, the bomber had been stripped of its military purpose and left at Creel Airfield near Paris. Its engines and other parts were removed, its nose section was damaged in a ground accident, and the airframe sat outdoors without active preservation. Those years would have exposed the aluminum structure to moisture, temperature changes, and neglect, but the exact pattern of internal corrosion and fatigue damage is not fully documented. The former strategic heavy bomber was reduced to a stagnant, deteriorating hulk. The long timeline between its forced landing in 1944 and its ultimate grounding meant that the original wartime materials had passed through military, airline, survey, and storage environments before any museum restoration team ever touched them. Following the end of the conflict, the installation of 14 passenger seats transformed the bomber into a civilian airliner, initiating a highly invasive period of structural modification that stretched across multiple decades. The aircraft entered the post-war commercial environment as a stripped-down transport for Swedish and Danish airlines. This transition required extensive physical changes to the fuselage, placing the airframe on a path outside the normal American disposal system. At the conclusion of hostilities, the United States military possessed thousands of surplus heavy bombers. The vast majority of the intact fleet was flown to domestic storage facilities and systematically dismantled in industrial smelters to reclaim the raw aluminum. However, this specific airframe followed a different path. Because it had crossed into neutral territory and remained in Swedish hands, it was drawn into post-war diplomatic arrangements rather than the ordinary domestic disposal pipeline. After Sweden converted interned fortresses for airline service, this airframe passed through Swedish and Danish civil and military use before ultimately reaching the French Institut Géographique National. That unusual chain of custody, not a simple American sale for scrap avoidance, inadvertently shielded the bomber from the aggressive domestic scrapping program. That reclassification spared it from the salvage yards, but survival came at a structural cost. To meet airline requirements, Saab removed military equipment, installed 2 passenger cabins with a total of 14 seats, and converted the bomb bay into a cargo compartment with a mechanical lift. The airframe was later purchased by the French Institut Géographique National to serve as an aerial mapping platform. This second phase of commercial life required another rebuild. The nose was modified, and downward-facing cameras were installed in the belly for survey flights. The surviving record supports substantial modification for airliner and mapping service, but not every internal cut or reinforcement is documented. Each civilian role stripped away another layer of combat architecture, guns, combat radio equipment, wartime systems, and exterior markings disappeared as the aircraft was adapted for passengers, cargo, and survey work, leaving a hybrid airframe whose military origin was increasingly difficult to read. The heavy civilian modifications obscured the aircraft's wartime origins, so identification had to move beyond appearance and into serial records, registrations, and surviving wartime documentation. In 1968, an aviation historian confronted the contradiction between a derelict commercial airframe and archived military combat logs. The aircraft sitting abandoned on the French tarmac bore no external resemblance to a World War II heavy bomber. Commercial aviation regulations and decades of civilian service had mandated the complete removal of original military hardware, while repeated repainting had erased any visible squadron codes or combat insignia. The critical identification was Serial 4-2-3-2076, the wartime number tied to Shoo 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 Baby. The specific claim that Steve Birdsall proved the case by finding a manufacturer data plate is not confirmed in the available sources. The safer record is that he researched the aircraft's provenance and tracked the service history of F-BGSH back to the combat veteran. With the serial identity established, investigators could connect the abandoned French survey aircraft to the United States Army Air Force's records for the 91st Bomb Group. It was no longer a generic surplus transport, but a verified combat veteran whose altered civilian hull could be traced back to operational flying in 1944. That historical baseline changed the aircraft's legal and diplomatic value. It was no longer merely obsolete commercial equipment waiting for disposal. It had become a heritage asset requiring international negotiation over its final disposition. The French institute that owned the aircraft recognized the historical weight of that identification. French and American officials then worked through arrangements to preserve the bomber and return it to American custody. Sources describe this transfer with slightly different timing and terms. Some place the museum transfer in 1971, while others describe a formal French presentation in 1972. The safest narration is that in the early 1970s, the airframe was returned to the United States Air Force for preservation after nearly 3 decades outside normal military service. Legal custody did not solve the physical problem. The Air Force had acquired a structurally compromised shell, lacking functional power plants, flight controls, or intact aerodynamic surfaces, and moving that fragile hull across an ocean became the next operational hazard. Transporting a non-airworthy bomber across the Atlantic required reducing it to manageable sections. The team did not move it as an intact flying airframe. It was disassembled and crated at Creel, trucked to Rhein-Main Air Base in West Germany, and then loaded aboard a Lockheed C-5A Galaxy for the flight to the United States. At that stage, the goal was preservation and shipment, not a flying restoration. One account notes that the main wing spars were cut to ease transport, a choice that later complicated any return to flight. At the West German Air Base, military loadmasters faced the geometric challenge of sequencing the awkward, unbalanced fuselage sections into the massive cargo bay of the C-5A Galaxy. The center of gravity for each detached bomber section had shifted unpredictably due to the missing engines and the gutted interior equipment. Every dismantled segment required custom shoring, heavy-duty tie-downs, and specialized dunnage to prevent load shifting while keeping point loads off the fragile aluminum skins. The loadmasters distributed the massive weight carefully across the transport cargo floor. If the primary tie-down straps were overtensioned by the load crews, the resulting pressure could easily buckle the unsupported bulkheads during normal flight turbulence. Following the complex loading procedure, the C-5A Galaxy successfully airlifted the cargo to Wright-Patterson Air Force Base in Ohio. This completed the primary international extraction, but the operational transfer was not yet complete. The disassembled components required long-term stabilization and a dedicated facility capable of handling a massive, multi-year structural rebuild. This strict facility requirement forced a second major overland transport phase several years later. In 1978, the entire collection of dismantled fuselage sections and wing structures was loaded back onto heavy transport trucks. The specialized convoy moved the components from Ohio to Dover Air Force Base in Delaware. Moving the aircraft to Dover represented the critical operational pivot from a storage and transport phase into an active engineering phase. Upon arrival at the new facility, Air Force Reserve volunteers at Dover took physical custody of the project, and the 512th Antique Aircraft Restoration Group was formed to oversee the restoration. This specialized team transitioned the operation from storage and transport into a rigorous forensic rebuild. They inherited a dismantled hull, scattered through crated aluminum sections that were highly vulnerable to improper handling. The new team was forced to inventory warped metal, missing systems, and civilian alterations before any true reconstruction could begin. Establishing secure custody of the parts was merely the baseline requirement for the rebuild. Once inside the restoration hangar, the engineering team faced decades of changes that had to be understood and reversed. Executing the structural rebuild required a heavy investment of time and labor, defining the extreme limit of the restoration effort. The 512th Antique Aircraft Restoration Group confronted a strict number constraint. Rebuilding the aircraft consumed 10 years of labor and demanded roughly 60,000 volunteer man-hours to complete. That effort was driven by a demanding but narrower requirement: return the bomber to a safe, flight-worthy B-17G configuration for test and ferry flying, while reversing the most visible civilian mapping and airliner modifications. Restoring a compromised semi-monocoque fuselage without original Boeing factory jigs is a severe engineering challenge. This process of structural deconversion requires far more than merely unbolting post-war hardware. It demands identifying every undocumented cut made during the civilian operational era, removing the unapproved commercial reinforcements, and physically fabricating obsolete military bulkheads from raw materials. Because the aircraft was destined to fly again, the engineering tolerance for these fabricated parts had to match strict wartime aviation standards. The procedural burden began with the interior. The team systematically stripped out the remnants of the civilian airliner configuration, removing floorboards, soundproofing, and the mounting tracks for the commercial passenger seating. Clearing the interior exposed the full extent of the structural damage inflicted by the aerial mapping company. The lower fuselage had been heavily compromised to install downward-facing optical equipment. When civilian mechanics originally cut open the belly of the bomber for camera bays, they severed the continuous aluminum skins and internal stringers that absorbed flight loads. In a semi-monocoque design, the exterior skin shares the in-flight aerodynamic stress with the internal framework. Interrupting this continuous load path forces the surrounding metal to absorb higher stress, creating severe fatigue risks. To restore the original structural rigidity, the restoration engineers had to fabricate and rivet entirely new continuous alloy sheets and internal ribs across the severed sections. Every new piece of metal had to be shaped by hand. Without the massive industrial presses used during original wartime production, the volunteer crews relied on localized forming techniques and manual rivet alignment. Rebuilding the complex compound curves of the forward fuselage and the bomb bay doors required thousands of individual custom-fabricated aluminum patches. The team painstakingly reverse-engineered the missing stress-bearing bulkheads by cross-referencing archival blueprints and measuring intact sections of the surviving airframe. The restoration also required sourcing major mechanical components that had been discarded decades earlier. The team located and installed replacement wartime specification radial engines to populate the 4 empty engine nacelles. They rebuilt the intricate cable-driven flight control systems that had been rerouted around the civilian modifications. Each of these mechanical installations had to be meticulously integrated into the newly fabricated airframe structure. Executing this structural deconversion required continuous discipline. Replacing a single damaged or missing section could take days of measuring, cutting, drilling, and riveting. The slow, methodical nature of custom sheet metal fabrication is precisely what drove the time commitment to a full decade. The engineering team could not simply ignore the survey aircraft modifications or leave major systems incomplete. They had to rebuild the airframe and systems to a safe, flight-worthy standard while returning the aircraft to a recognizable wartime B-17G configuration. By the end of the 10-year phase, the heavy investment of 60,000 hours had successfully transformed the gutted commercial transport back into a structurally sound heavy bomber. The fuselage was fully sealed, the load paths were correctly reestablished, and the power plants were mechanically secured. Completing the structural rebuild left the airframe fundamentally sound, but the newly fabricated metal presented an immediate environmental vulnerability. The engineering team faced a conservation trade-off between historical visual accuracy and the practical result of the rebuild. During its brief wartime service, the bomber operated in a bare metal exterior finish. But the restoration left the aircraft with extensive sheet metal work and visible differences between old and new panels. A bare metal finish would have exposed every repair and made the surface look less like a coherent wartime aircraft. To stabilize the surface and present a unified restoration, the team finished the aircraft in camouflage rather than natural metal. The paint protected the repaired skin from weathering and visually unified the old and new sheet metal without relying on an unsupported claim that bare metal would have guaranteed rapid galvanic destruction. Beyond surface protection, the olive drab and neutral gray finish provided a necessary visual masking effect. The hundreds of repaired and newly riveted sections created an inconsistent surface appearance, and modern replacement panels did not match weathered wartime skin. By applying a uniform wartime camouflage presentation, the team concealed the visible differences created by the restoration and presented a cohesive military profile to the public. With the airframe painted and the structural integrity secured, the project transitioned into its final operational phase. Ground testing a newly reconstructed heavy bomber demanded rigorous validation of every mechanical system. Mechanics conducted engine run-ups, checked fuel, oil, hydraulic, and control systems, and watched for the vibration problems that can appear when 4 radial engines operate on a restored airframe. The engineering objective was not to create an unrestricted military aircraft, but to prove that the restoration was safe enough for shakedown and ferry flights. The proof of the structural recovery came in October of 1988. The bomber, previously reduced to an engineless shell, taxied onto the runway at Dover Air Force Base. After shakedown flying, the restored aircraft flew under its own power to Dayton, Ohio, where it arrived for the National Museum of the United States Air Force ceremonies. The flight demonstrated that the rebuilt structure, systems, and power plants could sustain the controlled stresses of ferry flight. That landing marked the success of the restoration phase. The aircraft had been stripped of its invasive civilian configurations, returned to a recognizable B-17G wartime profile, and protected for public display. It remained at the Air Force Museum for decades, but that was not its final institutional chapter. After the later exchange involving the B-17D known as the SWOOS, Shoo 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 Baby began its move toward the Smithsonian National Air and Space Museum's Stephen F. Udvar Hazy Center for future display.